Thank you all for coming, and thank you for showing interest in this project. And I hope you're going to find today really interesting. And I'd like to thank those people online, especially our expert liaison group, and we'll follow up with you guys tomorrow. So please save some good questions for tomorrow and for the discussion later on today. I'm going to talk mainly about the passive seismic. We've got the MT guys following on and some regolith guys following on after me. So I'll give you a little bit more, expand on what Simon said about the passive seismic programme. It's not just GSWA. We have a lot of collaborators. Some of them are in the room, some of them are online. I want to acknowledge CSIRO, University of Sydney, GA, ANU, and Chinese Academy of Sciences. Some seem to get missed off that. There's a lot of people invested in this project. We are a very small team. We're just sat around these two tables. So we've gone out and we've got some other experts helping us, and we thank them very much for joining our programme and believing in what we can do. We've seen this map before. My first gripe when I saw this map was how many measurements have been made in WA? I can count not many. We're changing that. We're changing that significantly. But, you know, we're not going to set out to disprove them. We're just going to show them where things really are, where all these critical boundaries are in WA, because we've got receivers here, we've got earthquakes around, and then in the previous phase and this phase, we've got earthquakes here too. We've got a whole talk on the earthquakes of Western Australia coming up. We've seen this picture. 3 projects have been running: passive seismic, MT and regolith mapping, 9 phases, 160 points. Phase 1 was down in the southwest when we showed you these pictures last year. Phase 2, which is what we're going to be talking about today, is Esperance, Eastern Goldfields, Geraldton. Might look a bit of a weird phase. Partly geology says let's expand what we've been on, and partly logistics, let's get a whole nice block of data together. We want to do a multi-scale approach. We've got certain techniques which really only look at the top few meters. The regolith, we're going to dig a hole, a spade depth. I really can't be bothered digging any deeper, and that's where we've got the soils from. We're doing passive seismic site characterization. That's great for the area around. It'll see a few hundreds of meters down. We've got Huayu, who's going to tell us all about the whole depth of the crust. We're looking right into the lithosphere. When does the lithosphere change to the asthenosphere? We're going to hear about that. We want to get... so these projects so far have just looked at a particular aspect. Our next stage, which we haven't reached yet, is how to integrate these things into a top-down model. Let's just go back, because the pictures you're going to see encompass both phases. Phase 1 encompasses mainly the you and me terrain, Perth Basin, Pinjarra origin, and a bit of the Albany Fraser come round the bottom. So we'll just have a look at some of those pictures we got from last year. So we got the depth to MOHO, we got VP-VS ratios. We started seeing those east-west structures that Klaus was talking about earlier this morning. We were getting some nice cross sections. I think one thing, we've got somebody who's going to go and look at some of these cross sections in more detail and really tie the 3D structure into this. We got some 3D velocity models out of this. We got the very shallow crust. Last year we contoured all our images, which looks really great, but you know, there is 40 kilometres between 40 metres for each station, so it's ambiguous, but it gave us some nice results. And then mantle structure. This is what we've been selling the project on. We thought last year, when we saw the depth to LAB and the coincidence of the gold, we thought, yep, we're onto a right winner. And then we all said, what happens if you go further east? Well, we're going to find out today. So east trending structures seen in the MOHO and other crustal features. This was from last year. Remember, that's only half the data so far. What's going to happen to these features once we cross that I default? Are we still going to see them in the Eastern Goldfields? Lithospheric keel, as I said, this is what we were dining out on last year. What happens when we go to the Eastern Goldfields? Is it going to go across the way? Gold deposits sit along that gradient. That gradient at the minute isn't heading towards the Eastern Goldfields. What's this going to tell us about the lithospheric keel under the whole of the Yilgarn, not just the you and me terrain? What does this tell us about craton formation, and what is that going to imply about mineral deposits? Phase 2. So we went north for a bit, and then we went east. Eastern Goldfields starting into the Albany Fraser, both very mineralised zones. There's going to be a lot of interesting results coming out of this, hopefully. 166 new stations in the ground for a year, March to March of 2024 to 2025. Now, people say, I've just picked them up and I've just moved them. How are you going to integrate this year's with last year's? It's easy. We fail. but then we go and repeat some stations. Those stations which repeat end up stitching this together. We also have a backbone of the permanent stations and the old Oz array stations, again, to help stitch all our phases together. And then we started having some fun. I can't deny it, it is rather nice flying helicopters. There are a lot of logistics associated with that. It's not a trivial. So we've taken, I don't know, there are about 30 points out of the 160 which we were flying by helicopter. It actually doubled because we had Kalgoorlie loved it. They had a massive rain event and we couldn't actually drive anywhere. So we had to fly, which was really beautiful. But that is going to really stand us in good stead when we come into phase 4, when it is 100% by helicopter. We've had a lot of practice now, but it's taken some time, taken a lot of experience. And the helicopter pilots as well, they've not done this sort of work before. Phase 2 products, there's a lot, and here is the volume. For some reason, it has a different cover from the one I'm just about to show you. There's 10 of these in the room. You may touch it, but you may not take it away because it has a draft written right across the front of it. But do have a flick through. And in it, you'll find the details on how all these wonderful products were made. And at the bottom, you'll see some interesting things: atmospheric models, asteroid entry, space junk re-entry, space weather. It's not just you mineral hunters that are looking at our data. We've got some other really esoteric people looking at the data, which is great. That's what we put the data out there for. Anybody can use it. And I'm glad some of these people have done some really interesting stuff with it. Data availability. The raw waveform data, if you are a seismologist or know anybody, they can get the waveform data from OzPass. If you just want the data, the maps, the models, they're on our system, the magic system. And as I say, coming soon, here in my sticky little mitt, is this. Okay, some of the uses of our data: environmental monitoring, groundwater levels. Your ambient noise changes with how much water you've got in it, or so it looks like from this comparison of between the ambient noise correlation between 2 sites over a year. That's a time function along the bottom. So this is an interesting development, and we're going to hear more about it. I think in a couple of weeks' time, the guy's actually done it across the whole of our stations. And this is the one that I love: seismoacoustic signals of fireballs. Fireballs are things entering the atmosphere which burn up, but that generates a seismoacoustic signal which couples to the ground, and that can be recorded on seismometers. We've got a bunch at Curtin having a look at this. And they've used our data. They've tracked one satellite re-entry with it, and that has quite some implications. There is so much junk up there, and it's all about to come back down because time's up, and we're only sending more junk up there. So this is going to be something that could be useful. Right, I've just got back from the field. I've hardly got rid of the dirt under my nails, and it's all good red dirt. Midwest has just come in. We have just completed the deployment for the Midwest phase 3. That's the green spots up there, hopefully ticking off the north of the Yilgarn and into the Capricorn, moving from the Perth Basin into the Carnarvon Basin. And again, you'll see a lot of green spots mixed with the purple spots. We're stitching it again. I'd love to say we were getting better at our data quality. We are, but there's actually some advantages of having the odd, as I say, the odd failure. The data, look out for it next year. We hope to get the raw data out within a year. The waveforms will be available. It will be able to take a little longer to get the report out. Phase 4, the Paterson. I've been talking about this phase for about 3 years now. We are now going there. It's really, really remote. And the people there have been, once we started talking to them, they've been really great. It's a whole new game talking to the people in these remote areas. But we're really looking forward to getting out into the Paterson area and seeing what there is to do there. As I say, it's all by helicopter, and we're going out next month to put, it's only a small phase, this one, 120 sites. The GA have come to the party. We're actually going to put some in the NT, just for fun of it, so we can stitch to the rest of the Oz Array network. And as Simon mentioned, hopefully we're going to get some new techniques on board. This geothermal looks really nice and neat, like you can put it in a helicopter, till you realise you've got to have a generator, a high pressure air compressor with you as well. So let's take this slowly. We're going to see if we can get all this kit in a helicopter, but it is a technique we're looking at, and if not, we're going to try and put it by road installations, either backtrack a little bit to one of the other phases, or we'll see if we can get some in by helicopter. The logistics of that is you put it in when you put your seismometer in, and you take it out when you take your seismometer out. So time-wise, it works really well. It has to sit in the ground for a whole year so you can get rid of the annual variations, and then you can get your heat flow out of it. I should have really mentioned the gas sampling. The gas sampling as well, we're an area of salt diapirs in phase 4. So we're looking at hydrogen, helium. I'm not going to try and blag my way through this. I'm a geophysicist. I really don't know anything on this. Anyway, here's some nice photos. I'm going to let the guys themselves talk about the individual models that they've come up with. Thank you.